Well, hello Internet, and welcome to part 4 of my C++ tutorial. In this part of the tutorial, we're going to cover while, break, continue, do while, exception handling, and we will be introducing more complex problems for you to solve. Like always, all of the code as well as a transcript of this video is available in the description underneath this video. And if you haven't watched any of the other previous parts, you pretty much have to, otherwise you might be confused, and I have a lot to do, so let's get into it. Okay, so here we are again. We are in NetBeans, and NetBeans is exactly the same whether you're on Windows, Mac, or Linux. Okay, so we're going to use our range function like we used in our previous part of the tutorial, and you can see all that information here. Like I said, in the description underneath the video, you will see that. Very first thing I'm going to talk about here is while, break, and continue. Now, we've talked about while briefly previously. Basically, a while loop is going to continue to run as long as a condition is true. However, whenever you create a while loop, you're also going to have to first create a variable that is going to be used in the while condition before you create the while loop. Okay, so we created that. And what we're going to do here is I'm going to create a while loop, and I'm going to say we're going to continue to loop as long as the value for I is going to be less than or equal to 20. Of course, we're going to use our curly brackets, and of course, we are going to have to increment the value of I, and I'm going to use the shortcut, this guy right here, and this is exactly the same as, as I plus 1. Okay, those are exactly the same thing, just a shortcut. Okay, so what I want to do here is I want to come in and check if a value is an even value, and if it is, I want to skip it. I don't want to print it out on the screen. So how can I do that? Well, I can go if, and I can go I, and modulus 2 is equal to 0. That means there is no remainder after a division by 2. Well, in that situation, I'm going to increment the value of I, and then I want to jump back up here and start going through the loop again. How do I do that? Well, I just use continue. That is exactly what continue does. All right, so continue is going to skip everything that comes after here. We don't need to worry about this incrementing because we already incremented it here. Just jump back up here and then check to see if the value is even again. All right, so that's good. So what are we going to do otherwise? Well, let's say we want to artificially break and jump completely out of the loop and jump down to this area down here. Or let's just end our program with return. How can we jump completely out of the loop? Well, we're going to use another function called break. So what I'm going to do here is I'm going to say if I ever has a value that is equal to 15, in that situation I decided I don't want to check up to the value of 20. I just want to break out of the program. Well, or break out of the loop, and that's exactly what break does. Otherwise, I want to come in here and I want to print out all of the odd values. So I can do that, easy enough, and there we go. And of course, we need to increment the value of I so that we can continue, and so eventually the while loop will end. And if we run that, you're going to see over here, it prints all the values, all the odd values up until 13. And why doesn't it print more? Well, because we broke out of the loop whenever we had 15. Okay, so quick example of how to use while and continue. And now we're going to get to our first problem. Okay, so this is probably going to be one of the first somewhat complex problems you're going to have. What I want you to do is I want you to create a program that is going to draw pine trees on the screen after asking the user how many rows they want. And sample output for our program is going to go along these lines. We are going to ask the user how tall is the tree. They're going to say 5 rows, and then we are going to print out 5 rows along with the stump of the tree. Okay, so that is our goal. So you could pause the video right now and try to create it. Otherwise, I'm going to give you a couple hints in regards to how we might go about solving this. And then after that, what I'm going to do is I am going to actually write the program. So you can stick around for the hints if you'd like. All right, so first let's analyze exactly what's going on here. So we have 1, 2, 3, 4, and that's it. So we have 4 spaces and then we have a hash symbol. Okay, so what do we have here? So this is the next row. We have 1, 2, and 3. So we go from 4 spaces to 3. And then down here, 1 and 2. Then we have 2. And then we have 1. And then you could also see that the number of hashes goes from 1 to 3 to 5 to 7, and so forth and so on. So as we analyze how to create this, what we want to do is we want to come in here and think about what we got. So what I need to do is, to make this program work, is 1, I'm going to need to decrement spaces by 1 each time through the loop. Okay, so I know I need to do that. And what else am I going to need to do? Whoops. I am also going to have to increment the hashes by 2 each time through the loop. And I'm going to have to save spaces to the stump, because I have to do a stump each time, by calculating tree height minus 1. I'm also going to have to decrement from tree height until it equals 0. Another thing I'm going to have to do is print spaces and then hashes for each row. It's always a good idea to list out what we need to do with our program. And the last thing is print stump spaces and then 1 hash. Okay, so that is the goal of this. Is called a use case. What I did was I basically just looked at what we need to do here with our program and listed out all of the things that I need to do to accomplish what I'm trying to do. So let's go and just mark that off right there. And then, knowing all this stuff, let's go and create our program. And you could, of course, pause the video here and go and do it. Otherwise, I'm going to solve it. So the very first thing I need to do is I need to ask the user how tall is the tree, just like we were told to do. Then I am going to store that value, but first I'm going to have to actually create a whole bunch of variables here. So I'm going to create an integer. And what sorts of things are we going to have to store? We're going to have to store the tree height, which I'm going to set for 0. We are going to have another thing that's going to be the spaces before the hash. We are going to have to calculate how many hashes we are going to start with. We're always going to start with 1, so I'm going to set that to 1. And then we're also going to have to calculate the number of spaces before we create our stump. All right, so we know those are the things we're going to need to get. So I know that I want to get the tree height from the user. That's something the user provides. That's the only thing the user provides. And I am going to then have to figure out how many starting spaces. Well, the number of starting spaces is going to be equal to the tree height minus 1. We know that because we counted them. See, this was 4 spaces, 3 spaces, 2 spaces, 1 space. So what we're going to do is we're going to say our starting number of spaces is going to be equal to whatever the tree height is minus 1, because that's what it is, and then we will decrement it from there forward. We're then going to have to figure out the number of spaces before the stump. Well, you can see that this is exactly the same as that hash. So there we know that we can get our stump spaces directly from our tree height. So let's just go and put tree height minus 1 rather than copying from spaces to there, which we could do also. And then we need to go and create our while loop that is going to allow us to have all of this stuff work. So what we're going to do is we're going to say, while our tree height is not equal to 0, and of course we're going to be decrementing the tree height as we create our tree. We then, inside of here, want to print the number of spaces we have, and thankfully we have our nice little handy dandy range function we created previously. So let's just go auto and X, and we'll call range to automatically generate this vector for us. We're going to say we want 1, 2, whatever the number of spaces is going to be equal to, which we know it's going to be tree height minus 1. So trace, and then we want to increment that by 1 each time through. And then we want to print our spaces. So we'll go C out and the number of spaces. And if you're not getting this, don't worry about it. The whole idea here is just to get your brain to think in new ways and to explore ways of using C++. It's not to, you're not failing if you're not getting all of these right. Okay, so then I need to print my number of hashes. So this is going to be basically the same type of thing. We're going to say range 1, and how many hashes we need to print, and then 1. And then we just need to print out those hashes. So we'll go cout once again, and then we'll put hashes inside of there instead. So there we go. We are printing our spaces and we printed our hashes. Well, after we do each one of those rows, well, then we're going to have to go and create a new line. So we'll just create a new line to jump down to the next space. We don't have to concern ourselves with what goes on with our tree on, after the hashes are printed, because, that doesn't matter. So we'll throw in a new line here. Then we're going to have to decrement both our spaces as well as our hashes. So we're going to say spaces is going to be 1 less than what it previously was, and our hashes are going to be equal to, they're going to increase. So we're going to say they increase by 2, just as we see with our tree, and just as we wrote here. See, increment the hashes by 2, decrement the spaces each time. See, that's all I'm doing, is just going and taking this and converting it into code. That's why it's always good to, print it out. And then finally, or list it out. We're going to decrement our tree height because it needs to be decremented. Okay, that's all I did. I went and listed what we needed to do, and that's it. And our while loop's going to continue until there is no more tree that needs to be printed. Then after that, what we need to do is print our stump. So I'm going to say for and auto x and call our range function once again, and we're going to say we want to go from 1 to whatever the number of stump spaces are. We're going to increment by 1, and then we are going to print out a whole bunch of spaces for our little stump here. And then we don't need to do any type of looping for printing out the final stump. We're just going to go, because it's always just going to be 1, we're going to just print out the one singular stump, and that's it. We did it, I think. Let's run it. How tall is a tree? Let's say 5, and there you can see. Works perfectly. And how big is the tree? Let's go 6, and you can see it prints that once again perfectly, and we can go again. What happens if we do 2? You see it looks a little bit weird, but it didn't indeed print 2 spaces. All right, so hopefully you guys got that. If you didn't, that's okay. Whole goal here is just to understand the code that I wrote. And now what we're going to talk about is exception handling. Now I'm going to start off with the basics of exception handling. Then after I cover classes in a later tutorial, I'll then come back and show you how to create custom exceptions. But this stuff's useful also. It's very useful. All right, so exceptions are basically just errors that occur when things don't go as expected. So for example, you might have a program in which you expect the user to always enter integers, and they go and they enter a string. Or you expect a file to be available, and it isn't. Or you expect the user to not enter 0, and they do. And that's basically it. It's exceptions to what you expect, and then what you're going to do in those situations is handle those situations. So what we're going to do here is I'm going to cover a potential division by 0 error. So the user is going to enter in 2 numbers, and one of them could potentially be a 0. And we're going to handle that situation. So we're going to say that we want the user to enter in 2 values. So enter number 1, and then we're going to go and get that value and store it in number 1. And then we're going to do the same for number 2, of course. So just go enter number 2, and this is number 2. Now, to handle the potential problem, we're going to try to do something that could potentially cause an error. So we're going to say if number 2 is equal to 0, well, in that situation, we know that we can't do that division. So we are going to throw an error, and we're going to describe what that error is. We're going to say division by 0 is not possible. Okay, so we got that set. And if the user doesn't enter 0, well, then we are just going to print out the solution as if nothing went wrong, because nothing did go wrong. So we're just going to say something like, here's a float divisible by, and here's another float with 1 decimal place, which is going to be equal to, and let's say we want to accept 2 for our final answer, and num1, num2, and then underneath here we will say num1 divided by num2. And there we go. But we threw this error. What does that mean? Did we just throw it off into nowhere? No, we have to catch and solve or handle the error. And how you do that is you call catch, and then you're going to receive a message in this situation. And this is going to be the exception. And then what I'm going to do is get that message that was sent out, and I'm going to handle it. So I'm going to say something like error, and this keeps our program from completely collapsing and crashing and throwing errors all over the place. Instead, we just send a nice happy message and end our program gracefully rather than allowing it to collapse. So let's run it. And what did I do? Oops. Okay. CN, of course, and CN. All right. Now we got that set, and let's run it. There it is, number 1, and let's just do 4 and 5. Everything works fine. Everybody loves everybody else. All right, so let's try this. 5 and 0, and you can see it just prints out the little error message that I have here, and it doesn't crash. It doesn't throw all kinds of nasty things all over the screen. It just prints a little nice little message. It could go back and continue, maybe asks for numbers again, do whatever it likes, but you can see it gracefully ended. Okay, so there is one example of how we can handle exceptions. And now I'm going to show you another. All right, this time I'm just going to go and throw an exception without really any meaning, just so I can demonstrate a couple other things. So we're going to go standard cout and just throw a message on the screen here so we can see what's going on. So I'm going to say throwing exception, and then we'll be able to see what's going on. Then I'm going to go throw, and rather than just throwing a string, I'm actually going to go and throw an actual error. So we'll go call this a runtime error, and error occurred will be the message that we send along with what we're sending. And then just for the heck of it, let's see if we're able to get here. After we throw our error message, I'll say something like, can you print me? And we will find out if, we lose all the code that comes after throwing the error or not. And then we can come down here and we can catch our exception. So I'm going to say catch, and we can specifically say the type of exception we want. And in this situation, we're going to use the standard exception, which is the exception from which all other exceptions are built. And like I said, I'm going to show you an example of that later. And then if I want to get the message that was actually attached to this exception, I can do that. I'm going to say handled exception, and we can go and print out our message. And how we do that is we just reference our exception, and we call a function called what. And that's going to print out this error occurred, this guy right here, okay? That's what we attach to the exception. So we'll say what, and then we will go and print a new line. And what else do we want to do in here? I think that's all we want to do. Another thing that's nice to know is you can always put a catch-all if you're thinking that there's a potential that an exception could happen. You really don't want to do this, but if you can't find any other way out of it, this is a catch-all. This will catch every single exception. And this will be our default exception. And throw a new line in there, even though we're not going to get there because our other part's going to handle it. All right, let's run it. And you can see right here, throwing exception is triggered. You can also see handled exception is then called, and error occurred, which is what we printed right here, was sent over to it. Error occurred, that's where that came from. And then you can see that nothing else happens. That means that if you throw an error or an exception, that all of the other code inside of the try block is going to be skipped. Okay? So real quick, 2 examples of exceptions. Like I said, more advanced information on exceptions is coming soon. But now I want to talk about do-while loops, and then I want you to create one. All right, so I'm going to be using random function generation, random number generation in this tutorial, or in this code. So what I'm going to need to do is I'm going to use something called ctime, and that's just going to give me the number of seconds that have passed since January 1st, 1970, and I'm going to use that as a way of generating a random number. So what we're doing here, though, also is we're going to be covering do-while loops, and basically the difference between a do-while and a while loop is do-while loops are guaranteed to execute at least once. So what we're going to do is we're going to create a secret number guessing game. So we're going to first generate a random number from 0 through 10. But to do so, we're going to need what's called a seed. And that is just going to be a number that is going to help us create different numbers. So as seconds change, as our program runs, the random number is going to be based off of those changing seconds. And how you create a seed is you go srand, and then you give it something that's going to constantly change, like the number of seconds. And there you go. You just created your seed. All right. And now what we're going to do is we're going to go and create our secret number. So I'm going to go secret num is going to be equal to standard random number generation. And what we want to do is if we want to create a value from 0 to 10, for example, well, what we're going to do is we are going to say modulus 11. And you're basically never going to get it's basically going to be impossible, no matter what number you would divide by, for you to get a remainder bigger than 11 if you use modulus, okay? Because that's how remainders work. So if we want to go from 0 to 10 with our result, we're just going to go random number modulus 11, and that's going to give that. The user is then also going to guess what our random number is going to be equal to. And I'm going to give that a default value of 0. And then we're going to use our do while loop. So I'm going to say do, and it's going to continue doing everything. And what I'm going to do is I'm going to say standard out, guess the number. The user is then going to plug in some number. We are going to store it in the variable guess. Then I'm going to say if guess is greater than secret num. Well, in that situation, I'm going to print out a message, and it's going to be that they entered a value that is too big. And then likewise, if they entered a guess that is less than, I'm going to say too small. So I'm going to help the user basically figure out what the value is. So I'm going to say too small in this situation. And there that is. And then what can we do after that? Well, not really anything, except go while we're going to define how long this is going to run. So we're going to say that this is going to continue to run as long as the secret number is not equal to whatever the guess is. And don't forget that semicolon. If you have any problems with do while loops, it's probably because you forgot that semicolon right there. So make sure you include it. And if we ever get outside of the do while loop, what does that mean? Well, that means that we, or the user, guessed the number. You guessed it. All right. And then we can go and test our program to see if it worked. There we are. Guess a number. And I probably should have said from 0 to 10, but I didn't. So I'm going to say 5, too small. So then I'm going to say 7, and too small also. In which I'm going to say 9, and that's too small. And then I'm going to guess 10. You guessed it. All right, good. Let's run it again. Guess a number. 5, too big. I'm going to say 3. You guessed it. Okay, so we can see that our program is working, and you see an example of a do while loop. Now, a lot of programs don't have, or programming languages do not have do while loops. And what I want you to do for our final problem today is to use a while loop to create a do while loop. So basically, what I want you to do is to take what we previously did and have it work with just a while loop, but have it work in pretty much exactly the same way. So what we're going to do is I'm actually just going to leave this here. I'm going to bring back what I previously deleted. There's all this stuff. And you can, of course, pause your screen if you want to go and try to create this on your own. And I have to think about what sort of things am I going to need to work here. And what sort of things do we learn about in this tutorial that we can use to create a do while loop? Well, I want this to continue to execute over and over again until a condition is reached, okay? And that's what we have down here. So how can I do that? Well, one thing I can do is I can go and create an infinite loop with while and true. And then what I can do is I can break out of the actual loop when a situation occurs, which is going to be this situation right here. So instead of using the while loop down here, I can just copy this, paste this inside of here, and instead go if, and secret number is, but I'm going to say equal to guess instead of not equal. Well, in that situation, I'm going to call break, and that provides me with a way to jump out of my program. Then what am I going to need to do? Well, I'm going to need to come in here, and I'm going to need to, of course, ask the user for a number. So I'm going to take that and paste that inside of there. I'm also going to have to store the guess, and I'm also going to need to tell the user if it's too big or too small. Let's go and steal all that information also and paste that in there. And now you can see here is basically something that is kind of worthless. So let's get rid of that. You can see here our ready-made do while loop is actually less lines of code and a little bit more understandable than our do while loop. And this is one of the reasons why a lot of programming languages do not have do while loops. So we can go and save this and we can run it and we can see, guess a number, and I'm going to say 5, too big. I can say 3, too big. I can say 2, too big, 1, and I guessed it. And then we can run it again just to verify that it's working. 5, too big, and we can go 3, too big, and 1, you guessed it. Make sure. Let's see if I got something the same 2 times. Too big. Is it 1 again? Oh, too small. Okay, so it is working properly. Just gave me 1 2 times in a row, and it sort of made me nervous. So there you go, guys. There is working code for a do while loop and some more complicated problems. Of course, as the tutorial continues, the problems are going to continue to get more complex. Hopefully you enjoyed that, and like always, please leave your questions and comments below. Otherwise, till next time.